All right, lesson 4.6. So last class when we were doing lesson 4.5, we talked a lot about asymptotes, vertical asymptotes in lesson 4.5. Today, we're going to be dealing with inverse trigonometric functions, also known like as arc sine, arc cosine, arc tangent, which I'll show you in just a moment. I'm going to open this up because there's something I'm going to pull out first before I get started. Is I'm going to go open up the calculator from our pre-programmed list. That is, if it opens, number 14. I use calculator 14 today for, well, at least on the bell ringer. That's from last class. So right there, graphing trig functions. I'm going to open that one up. And not only that, I'm going to go back to this 4.6 instructions. The unit circle help. I'm going to be using this unit circle right here, which comes from this document, unit circle help. If you click that, that's where I copied that photo from. It's right there. If you want it to follow along at home, or if you want to know where to get one, that's where you go. But I'm going to leave open the trig graph first. So number one asks us to find the vertical asymptote and sketch the graph of y equals 2 secant x. So I'm going to clear this just to make it easier to see first and foremost. So we want to know where are the vertical asymptotes for 2 secant x. So as you can see this graph, I'm actually, as it turns out, my first asymptote I've thrown in there is in the right location, but an asymptote, by way of reminder, this actual graph, 2 secant x is shown in blue, has gaps in it. There are areas where this graph does not exist at all. Domain values where the graph doesn't exist at all. I know there looks like there's a huge gap here, but as far as the domain goes, there's not a huge gap because the domain is used down here below. But these two parabolas, and that's what they are if you zoom out, they look like a bunch of parabolas, do have a break in between them. It's not all reals. There's breaks in the x-axis, and that's one of them at pi over 2, which we're about to learn. That's what that is, pi over 2. And so the question I'm going to lead off with today here is if you're trying to find a vertical asymptote, how do you actually solve for that mathematically? What is it we do to solve for a vertical asymptote? So different things I've seen and heard is that we need to find the ratio. We need to use the unit circle. And I agree with all those, but just to directly answer the question, mathematically, how do we solve for a vertical asymptote? These occur, or they don't truthfully occur. We plot them whenever we're dividing by 0. That's what breaks up the graph. So the 3 steps I gave you last class is 1, to determine the ratio so that we could find out what is doing the dividing and the function secant. That's the first thing we need to determine. What is doing the dividing on secant? And so over on this graph, I'm going to slide all the way down to the bottom so you can see the 6 trigonometric functions. And I went too far when I covered that up. Let me go there. There we go. And so now when I see secant, I can discover, oh, secant is the same thing as the hypotenuse divided by the x value in terms of right triangle trigonometry. Okay, so if a vertical asymptote is created whenever we divide by 0, then what I need to do here is solve for when x equals 0. And as stated by a student earlier, what's the best way of solving for when x equals 0? It's the unit circle. We're going to use the unit circle, and we're going to determine when does x actually equal 0. So what angle does x equal 0 at? And so using this unit circle here, I would go around until I found an x value of 0. So remember, these are the x's. It's every point, every coordinate point is x comma y. So I'm just looking for 0. And specifically the very first one, there's the very first 0 that's an x. And so the angle that it occurs at, in terms of radians, not degrees, is pi over 2. And so that's where this occurs at. So what does that mean? Well, we just determined that if there are no horizontal asymptotes, excuse me, let me say it again. If there's no horizontal discontinuities, Nope. Try one more time, Mr. Voorhees. If there's no horizontal transformations, there we go. Let me write and then I'll talk. If there are no horizontal transformations, that's where the first asymptote is going to occur. Now, there may be some horizontal transformations. Let's check. So here's what our third step was. We write out the pi over 2. And with trigonometry, without transformations, each asymptote occurs in pi away from one another. So we started here. We started with the initial angle, and then we add in pi to find all the others. And on this particular problem, when I look up, I have no horizontal transformations, none. Now, this right here is a vertical. It's on the outside. It's multiplying times the secant there. You can see that's a vertical transformation. And I know you would think, oh, well, if it's a vertical stretch, surely that affects my vertical asymptote. The answer is no, because even if you stretch this dotted line upward, it already goes upward forever. So stretching it doesn't change anything. Only horizontal transformations make a difference. So since there are none, all you have to do is say that n is an integer, and we are done. This formula right there would solve for all the infinite number of asymptotes. And so when you check what I had over here, you'll see, let me zoom in a little bit. You'll see that that does pi over 2 creates the first asymptote, and that they are in pi away from each other. I can test this by moving around n. And so if I make n 1, you get the first asymptote to the right. If I plugged in and made a -1 for n, you get the first asymptote to the left. -2 would provide the second asymptote to the left, and so on and so forth. It's same for the positives. So all that's happening mathematically when you plug in an n value that's an integer is it just determines what the next or some number of asymptotes away from the original. So whatever n is, if n is 5, it's 5 asymptotes away to the right. So it's 1 asymptote, 2, 3, 4, that would be 5. So that was what we went over in lesson 4.5. Now, in previous lessons, we specifically lesson 4.3, we did unit circles. So let me copy this in here. And I gave you values, and I said, hey, what is that value if it exists? And I trained you how to use a unit circle. And so we would look for tangent of -2 pi. So if you look over here on this, let me just copy this here to also copy. Okay, if you look on this, you're looking for -2 pi. And you can see on the angles, it's not there. And so you might remember this. We can use a coterminal angle. And so here's what coterminal. Coterminal means terminal, the angle ends in the same place, co, together. So they end together in the same spot. The formula for this was whatever your angle is plus or minus 1 revolution. Right, a revolution means a full circle. So in this one, I'm in radians, so I'm looking at radians. -2 pi is not on there because it's too small. So what I would do is I would take my -2 pi and I would add the revolution. And so 1 full revolution is a 2 pi. -2 pi plus 2 pi is 0, which means tangent of -2 pi is going to equal the tangent of 0. And we'll discover what that is once I remind you that tangent is y over x. Sine is y, cosine's x, tangent is y over x. So if I go to the angle 0, here it is. I'm looking, that's theta equals 0. And that's my y. That's my x. So tangent is y over x. So the value is going to be 0 divided by 1, which simply put is 0. That's our answer in this problem. All right, let's take a look now at number 3. Which angle has a negative sine value and a negative cotangent value? Now this honestly also was lesson 4.3. And so what I want to remind you here, actually, instead of using this.
Hey, Mr. Voorhees, I'm going to my ortho appointment right now.
Okay, so previously I copied that unit circle and there was a reason for that because I knew I was going to use it. So now let me use this unit circle. Okay, so on this one it says what angle has a negative sine and a negative cotangent? And basically they give us these angles, and none of these happen to be on the unit circle. Now, if you're doing some logical thinking, you could realize that pi divided by 7 is going to be in between pi divided by 2 and 0. You can just kind of see this is pi divided by 3, pi divided by 4, pi divided by 6 is there, pi divided by 5 would be somewhere in the middle, pi divided by 7 is going to be somewhere over in here. That would be pi over 7, which I'm going to say that A here is going to be a first quadrant angle, quadrant 1. That's where A would be. 5 pi over 7, that's more than 1/2. So think about anything divided by 7. Half of 7 is 3.5. Since 5 is bigger than 3.5, this is past half a pi, but yet 5 is not as big as 7, so it's less than 1 whole pi. So it's somewhere located in here. Now, if I were going to do my best dividing, I'm getting like 0.7 and some change. So it's going to be bigger than 2/3, which is 0.66, but smaller than 0.75, I think. So I'm going to guess that it's somewhere over there. I'm going to say that's where angle B would point. The terminal end of angle B would be right there in quadrant 2. I'm going somewhere with this here. Okay, just follow along, please. Here's 9 pi over 5. Excuse me, 9 pi over 7. Can't calculate. That's a little bit more than 1. But yet it's not, remember half of 7 is 3.5. It's not 1.5. It's not 10.5. It's less than that. So this would be somewhere over here. 7 going into 9. It almost goes in 13 times. It's almost 1.3, not quite 1.3. I'm going to guess it's somewhere over here. I could be off, but I'm just going to locate it there for the time being in quadrant 3. And I bet by now you've guessed where quadrant answer choice D goes. Let's see, 13 divided by 7. That's almost 2 pi. It's bigger than 11 divided by 6. 13 divided by 7 is somewhere over here. That would be answer choice D, located in quadrant 4. Okay, so now that I've written all that out, how could we solve for this? We know we have to have a negative sign. So sine is y over h. So if I have a negative sign, that means it's less than 0. And if it's sine, then that means the y divided by h is less than 0. And if I'm really interested in my y value, because on this is my y-axis, this is my x-axis, I could multiply by my h. And because of the math rule that h is always positive, my inequality will stay the same direction. Remember with inequalities, this is like an algebra 1 rule. If you multiply by a negative, you need to flip the sign or flip your direction of your inequality. If you multiply by a positive, it stays the same. H is always positive by rule, so the inequality stays the same direction. That means y is going to be less than 0. I just found out I can eliminate all of these. Any answer that's above the x-axis is going to be wrong because y has to be negative, which for our problem means A and B are out. Now the problem also said they have a negative cotangent. So cotangent is x over y. If you're checking over here, cotangent is x over y. So cotangent is less than 0. It's negative. Well, cotangent is x over y. That's negative. Now we know that y is negative itself. So real quickly, I'm going to just put in a little negative there. And so when I solve for my x here, I have to multiply by this negative number. I'm putting negative y, but I don't actually mean the opposite of y. I mean that y is negative, what we've learned. So those go away. But rule of mathematics, if you multiply by a negative, the inequality has to switch directions. 0 times anything is still 0. So this means x is positive. What I just now determined is that C is out also because x has to be positive. So the answer on this problem is D. So that's a review of previous lessons. Oh, and I didn't walk you through this. Let me just clear this calculator. What you could do also, this is a great little trick, is using technology. You could type in all of the answer choices. I'm just going to jump straight to the answer as sine and cosine. So let's just say sine to make this easy. And here, sine and, oh, cotangent. Sorry, it was sine and cotangent. Now just put A, and you could type in all your answers to check out, but we'll say it's 13 pi divided by 7. And you can see that both of these are negative, like they were supposed to be. I could switch that around. I just used A to make it faster so I didn't have to do this more than once. You could try a different one, like I'll try C, for example. 9 pi over 7. Notice that sine was negative, but here cosine would be, or cotangent would be positive, so that would not work. Okay, so there you go. That's just kind of a cheating way of using technology to come up with a solution as well. All right, let's start with some new stuff here.